Hello friends, today let us move ahead in the chapter applications of spectroscopy, in which we are going to do the topic luminescence. Okay, in luminescence we are going to cover phosphorescence and fluorescence. Okay, so first let us see what is luminescence. Now in spectroscopy we have already learned that absorption and emission of electron takes place, and when the emission takes place it is accompanied by some energy, okay, or some photons or some light. So luminescence is a word which is related to the emission of light by a substance when it goes from the higher excited state to its lower excited state. Okay, but the condition over here is it is not caused by heat. It is caused by due to some chemical reactions taking place, some electrical energy, or some bioprocess or radiations, but not heat. So temperature is not a reason for luminescence. Let us study. Let us see the next, the types of luminescence. We have some basic here. Photoluminescence is caused by the absorption of photon. Chemiluminescence is obviously caused by some chemical reaction taking place. Electroluminescence is caused by applying some electric current. Radioluminescence is some radiations. Bioluminescence is by some biochemical reactions taking place. Okay, so bioluminescence is related with the marine life, where they catch its prey by some radiations or by some photons or by some light. Okay, so let us study our topic, photoluminescence. Photoluminescence is again absorption and emission. Spectroscopy is whole about absorption and emission. What happens exactly when the molecule gets excited? Okay, so when a light is absorbed by a molecule, so the electrons in them, they go from the ground state to the excited state. Some heat is absorbed, some energy is absorbed, and when they go to its normal state, they give some light or they give some photons. This photons of energy, they make the things glow. So photoluminescence is nothing but they range from any visible light through UVs or X-rays or gamma radiations, and it is like temporary light absorption and subsequent light emission. So photoluminescence is strictly about the emission of light without any heat absorption. But what is absorbed? Light is absorbed. Okay, so no heating takes place here, the main thing. Now the types of photoluminescence, we have two. One is fluorescence and the other is phosphorescence. Fluorescence is immediate, instant. It lasts for a fraction of seconds, whereas phosphorescence, it lasts for more seconds. Okay, so fluorescence, when emission takes place immediately after the absorption, and it stops also when the incident light coming on is cut off, whereas phosphorescence on the other hand, it emits continuously even after the light is cut off. So it may take place in the range of like 10 to minus 4 to 20 seconds, or even it goes for minutes. Okay, and fluorescence takes place, the radiation's emission takes place 10 raised to minus 10 or 10 to 10 raised to minus 8 seconds of absorption. Okay. Now over here in fluorescence, the transition between the electronic states takes place of the same spin multiplicity, and whereas phosphorescence is taking place within two different spin multiplicity. Now let us see what this is exactly. S1 to S0 or T1 to S0. Okay. The electron in a normal ground state, one electron is in the clockwise direction, the other is in the anti-clockwise direction. When the electron absorbs light energy, okay, if it is going as it is in the same spin state, we term them as singlet. And since it is excitation, so this state is excited singlet state. But on absorption of light, if it goes in the excited state with the spin, reverse spin, the opposite, okay, both the electrons are in the same spin here, which is not so stable for the electrons in that atom. So this is termed as triplet state, and since it is excited state, so we term as excited triplet state. Okay, so singlet is the opposite spin and triplet is the same spin. Now exactly what is fluorescence and phosphorescence? Now excitation is taking place. Now S0 is the ground state, S1 is excited, S2 is the more absorbed excited state. Okay, so when energy is absorbed, the electrons they go from S0 to S1 or say to S2. Okay, now when they emit light, when the emission takes place, so if they are coming from S1 to S0 state, we term as fluorescence, that is with the same spin multiplicity. So fluorescence may what happens, fluorescence may the excited singlet state takes place. Okay, so singlet is, as already discussed, with opposite spin, and phosphorescence is the triplet state. So phosphorescence from S1, if the electron is changing its spin, we name as triplet state. So we have to write it at some other side over here, and we term as T1. Okay. Now from this T1, if this electron is going to the S0, the ground state, by emitting photons, light, that is your phosphorescence. Since more time is required over here, phosphorescence they stay for a longer period of time, whereas fluorescence, as soon as the radiations are cut off, fluorescence light is cut off, and phosphorescence they stay for longer period. I hope the things are clear. Okay, now let's see some examples. Fluorescence, the examples we can say, like when the light is put, you can go for some x-rays or medical to detect some cancers, tumors, the MRIs and all. As soon as the light is cut off, we cannot see the images. Okay, so the images are only seen once. In forensic sciences it is used, which can be visible like this something. Whereas phosphorescence, the neon watches which we have, the stars and all which we decorate in the bedroom ceilings, so when the light is put on, it absorbs light, and when the lights go off, the emission takes place for many minutes, many hours also, depending on the quality of that material used. Okay, so this was your fluorescence and phosphorescence. Fluorescence is for a fraction of seconds, emission cut, absorption cut, so there is no emission. Phosphorescence takes place for a longer period of time by emission of light. Thank you so much.